Great, thanks. My name is Nicole Kaplan, and I'm a computational biologist with the USDA, as Leah had mentioned. I'm responsible in this role for managing a lot of data so that we can learn how to sustain beef production in our western Great Plains. I will be presenting on a project completed for the Earth Data Analytics Program, which I call Precipitation Maps for Ranchers in the Rain Shadow of the Rockies. Managing rangelands is challenging because there's extreme spatial and temporal variation in environmental conditions, as well as plant forage production for livestock. It's also very labor intensive to manage the land and the livestock. Why do we care about rangeland management practices? Western Great Plains contain the most threatened grasslands in North America, but it's challenging for ranchers to sustain their working lands for multiple provisions. So we are vulnerable to losing land that provides conservation, critical habitat for birds, important cultural heritage, and food production. The Central Plains Experimental Range is a USDA research station established in 1937. Agricultural Research Service set up the Collaborative Adaptive Rangeland Management Experiment, which we call CARM, to evaluate effectiveness of adaptive grazing management at the ranch scale to achieve both production and conservation goals. In CARM, there are 10 pastures in a control treatment with moderate grazing all season, and 10 under an adaptive treatment, with one large herd rotated based on interpretation of rangeland conditions. This is a science-based, data-driven project. Across the CARM experiment is an embedded sensor network. My data analytics project goals are focused around getting data and information to stakeholders in time to make decisions about the big herd. For me, it's about working smarter, not harder. I have two main approaches for two different audiences. For my scientists, I've created automated scripts for data processing using the new Make utility and Python language, and a repository on GitHub for transparency and reproducibility. For our stakeholders, I contribute maps of precipitation to weekly reports to support decision-making, and I continuously communicate via Basecamp, which is a project management app, to get feedback on data visualizations, and then in turn, we refine our code. My contributions from being in the Earth Data Analytics Program have been to co-design visualizations with stakeholders and co-script with colleagues easily. Here's a list of improvements we've made in various iterations of our script. We've smoothed the map, we've made meaningful legends, we've used pasture names instead of numbers so it makes sense for our stakeholders, and we've been able to figure out the appropriate time range to calculate the precipitation accumulation that makes sense for plant growth. So now we have an automated workflow of precipitation data from field to stakeholder. Data from the sensors are delivered to a USDA server via telecom, which runs with the task scheduler on the server. Then the new Make utility automatically runs a Python script, which contains a series of functions that gets precipitation data, interprets the rainfall over the site using inverse distance weighting, which is predicting with greater weights for values that are closer to our sample points, classifies the values and maps them, and then exports an image that is emailed to the stakeholders who are making decisions on the ground. It is based all on a Makefile which documents the data files which the script is dependent on. And so as we update the data via telecom and revise the script with feedback from stakeholders, the workflow will run from the Makefile. In this map, we see where a deluge has hit the CPER, the latter during the week of between the 21st of June and the 28th. But since then, we've experienced very dry conditions. So it's even more important to get the data to stakeholders who are going to need to make decisions about moving the herd. Again, this is working smarter, not harder for me, in addition to faster via the smart compiling that the new Make utility can do. For our next steps, most importantly, we have a process documented within a GitHub repository. We have other sensors on the CPER that are part of the CARM experiment for which we need to develop a workflow for these data, and now we have a template for that. We have sister sites in a new USDA long-term agroecosystem research network across the country. We have neighboring ranchers who are interested in using data to drive their management decisions. We have a move to cloud computing, and we have exploring other methods for rainfall interpolation to do, including kriging. And with that, I just want to give a big thanks to my research leader, Justin Derner, an eco-hydrologist in our unit, David Hoover, who I've worked closely with, a remote sensing specialist, Rowan Gaffney, who I feel I can keep up with, and everybody at Earth Lab and my classmates in the program.